Welcome to the product video series, Map Suite Routing. Today we're going to be introducing the Map Suite Routing 3.0 product, and you'll learn the basics of how to integrate routing into your application. So for the agenda, we're first going to start off by answering the following questions. What are the Map Suite Routing product goals? What are some of the key product features? And what are the important classes? Then what we're going to do is we're going to get in the sample code that ships with the product, and that's where we're going to spend the majority of the video. So to start off, what are the Map Suite Routing product goals? Well, the first thing is that we wanted to provide a feature-rich routing component. And so that's at a high level. We wanted it targeted at medium-scale data sets. Of course, doing a data set like the entire US requires more of a multi-tier routing system, and we wanted to target something that was more in the medium scale, so something like a small state or a very large city network or a county, something along those lines. We wanted to be designed for flexibility and extensibility, so you could enhance it and do custom stuff with it. We wanted to support all kinds of line networks and not just roads, so it could support things like gas pipelines and things like that. We wanted it to easily integrate with our other products. We also wanted to expose to the developer an easy to understand and easy to use API. We want it to be professionally supported, so we've done a lot of training of people to be able to support it, and we wanted to continue to evolve it based on the community feedback. So those were our goals with this Map Suite 3 product. Next, what are some of the key features? We wanted to support routing point-to-point as well as sequential stops. So if you had a number of stops in between, we would support that. We wanted to generate turn-by-turn directions. So, turn left on this street, etc. We wanted to be able to optimize routes based on road types, such as highways or regular roads, speed limits, etc., and allow that to be kind of customizable. We wanted to be able to generate service areas based on speed and distances. So if you had a line network and you wanted to say, how far could I get if I could travel at this speed, for this amount of time. We wanted to support the concept of one-way streets. We wanted it to work with all kinds of line-based networks. We wanted you to be able to get up and running very quickly, and so we included some helper classes to help you with that. So if you do the routing and you get a routing result, you can throw that into what we call a routing layer, and you can instantly display that with some of our default symbology. We wanted to support the concepts of having areas to avoid or areas to stay within, and we'll show some samples about that in regards to that. And we wanted to allow you to pick various routing algorithms or implement your own, because the different algorithms have various strengths and weaknesses, and we wanted it to be flexible in that way. We also wanted to build it as a component so that it's easy for you to integrate in with an existing application, and then for it to be pure C# assembly. We also wanted to give you as many extensibility points so you have unparalleled control over customization. So like I said, with the algorithm, you have customization control over the index itself that it uses, over what kind of data it can integrate with. We've taken great strides to make sure that you can control almost every facet of the system for customization. So before we look at the samples, what are some of the important classes? The first one you'll see is Routing Engine. It's kind of the main class, and it really aggregates the other objects together, such as like the index and the algorithm and things. And so when you actually want to do a route, you'll be working kind of with the Routing Engine. We also have the Routing Source, and it's an abstract class actually, and it abstracts the underlying routing index. And so typically, we ship with a class that's inherited from Routing Source called RTG Routing Source, and RTG is a kind of a file extension of a particular index that we developed. But you could actually inherit from Routing Source, and you could create your own index in whatever formatted that you want it in. It could be, we have ours in a flat file right now. You could actually have it in a database or a different kind of flat file structure. The next one is routing algorithm, and this abstracts the actual algorithm itself. Out of the box, we have a couple different classes that inherit from routing algorithm. Ones that support Dijkstra's, graph, A-star, and bidirectional algorithms, and it's really straightforward to be able to add your own to that. We also have a routing results class, and this is kind of what comes out of the engine when you do a route, and it provides the feature IDs of the things that are in the route. It's also where you get the turn-by-turn directions from, and it provides I think either a line or a multi-line shape of the route to easily plot it or show it on the map. And one that's a little bit of a lesser player but pretty important is the route segment. And this is kind of the smallest piece of a route. It stores information about what the feature ID is, and then also things like the adjacent segments to it, the adjacent features. And these are things that we use inside of our index or inside of our routing source to be able to kind of walk the graph and apply the algorithms to. Okay, we're going to move fairly quickly here. Okay, so great. Now we're getting to the sample code. We're going to be reviewing the samples that ship with the product. They will come in C# and VB.NET versions. We're going to focus on the C# version. During the beta of the product, we'll only have the C# versions, but the VB.NET will be coming in future betas. We'll be moving fairly quickly to get it all in because there's a number of different samples, and it could take a long time to actually go through all of them in painstaking detail. But I wanted to give you a good idea about what the product does. We won't really be covering extensibility very much, though this is a rich subject and there's all kinds of different extensibility points. And really we need that as the next point kind of goes into, based on community feedback. So if we get a lot of feedback saying, hey, I want to implement my own algorithm, or I want to implement my own routing source as an index, then we'd be happy to create videos and stuff and samples on that. And please let us know what you think. We strive to be community driven, so if there's features we don't have, if there's features you'd like us to have, if there's changes, if just critiques on the API, anything, just please let us know. Alright, let's look at some code. You can find the code we'll be reviewing in the Map Suite routing product, so just go and download the evaluation. It's under the How Do I samples. We've got samples for 2005 and 2008 in C# and VB.NET. This is an extension, so it requires that you have a full or evaluation edition of one of the major Map Suite 3.0 products. So because it really depends on the core, so you need to have like a desktop, a services, a web, or a Silverlight product. And the evaluation actually just ships with a built-in evaluation of the desktop 3.0, so it works. So with all those little disclaimers and caveats, let's go ahead and look at the samples. Here we are in the C# How Do I samples, and let's go ahead and run through these. So as you can see, we provide a number of different samples ranging from simple routing to optimized road types and everything in between. And we'll be adding additional samples as we move the product forward. So the first one is really simple routing, and what this is going to show is here we have a start and we have the end, and it's showing the shortest route using, I think, the default routing algorithm. But we also have the fastest, which is using a different index that kind of gives a highway first priority, obviously going over on the highways at that point. So we're also using feature IDs here, so we picked a feature ID at the beginning and the end. And the rendering of the start location, end location, and then the route is actually in our routing layer. So when you call into the routing engine and you get the result, you can just pass that result into a routing layer and it'll just automatically display like this. So let's go ahead and take a look at the code for that. So as we had kind of talked a little bit about before, we have the routing engine, and then we're having two different routing sources. one that was built for shortest path and the other one for fastest. It really should be probably highway optimized, really. And inside the load, what we do is we take a feature source, which is actually a shapefile in this case, and we load Austin streets. And we really only need a feature source if we want to get back like the street names and things like that, though I don't think it's actually required once the index is built. And here we're going to create two new routing sources, and these are RTG routing sources, so they're using our routing source files. And here we're loading Austin streets and this alternate one, and we're creating a new routing engine, and here we're going to actually pass in the routing source into it and the feature source. And in this case we're not passing in the algorithm, but there's additional overloads where you can pass in the routing algorithm, as you see here. And see, it was really optional to pass in the feature source all along, and it's just really, if you pass in the feature source, it's just going to impact what results you get back from the routing result. But if you don't include it, you'll still get the feature IDs that interconnect it. Alright, so after you've went ahead and set that up, if we actually look in the, let's see, find path, what we're going to do is we're going to grab the first layer and actually cast it to the routing layer, because we've already added that. We're going to clear off any of the routes that are in that routing layer. Now, for the first time through, there shouldn't be any. And we're going to call routing layer.routes add. And what we're going to do is we're going to call that routing engine.getRoute, and we're going to pass into it the start ID and the end ID, and these are the feature IDs. And it's going to do the route, and it's going to return that back and then plot it on the screen. We could actually, on the get route, there's another overload that actually takes 2 point shapes, and then what we would do is we would actually find the closest feature ID to that point, so we can support that as well. And really, that's all there was. So, kind of in a nutshell, you create a routing engine, give it some sort of source like an index. You can optionally pass in the feature source, and you call the routing engine.getRoute. Now, there's other options that you can obviously include, like switching what kind of algorithm you use. There's the service area stuff. But as far as something being really simple just to get a route, really that's all there is. So let's go ahead and run these samples again, and go to the next one. Here we're getting shortest path by coordinates, and this is what I was kind of telling you before, where we have a start and an end coordinate, and these are just in decimal degrees. We're not actually specifying the feature ID, and it finds the closest feature ID and then does the route for it. So that one's pretty simple. Also, there's a get road information by ID, and this kind of represents what I was kind of talking about with that route segment. So if we take feature ID 8229 and we get its road information, what we actually store in our index is this feature ID and then the adjacent feature ID, or the feature IDs of the adjacent segments to it, and their route direction. So, and this is going to help us later for doing one-way streets. We can say, well, this is a one-way street this way, and so these other streets can't enter into it, and things like that. So this is just kind of a simple sample to show you kind of the concept of that route segment. Building routing data. Now, as you saw before, we loaded that routing source, and that routing source was an RTG routing source. Well, to actually generate the file, you have to generate your routing data or generate your index. And so in this sample, we just show some different purposes. One, we're going to generate one for the shortest path, one for the fastest path, and one optimized for highway. And it's going to target the file called shortestpath.rtg, and we can click build. And this operation can take a little while depending on how big the data is. I don't think this data is all that big, so we'll just click it and wait a little bit here. Now, the actual source for this, in our case is a shapefile, but the actual source could really be any kind of feature source. So it could be, data out of SQL Server, out of PostGRE, out of Oracle. All of those we can get data from and build this RTG routing index. And then when you go to do your route, you saw that it takes the feature source object. Well, that could be an Oracle, feature source, or a Microsoft SQL Server feature source. Even the fact that we have this RTG file and that's a routing source, you could actually create your own custom routing sources that actually stored the data back into SQL Server again. So there's no flat files whatsoever. So anyway, it created that, and let's go ahead and take a look at how it did that. So building routing data, and this one has a couple different ways. So we'll just take a look. And here we hooked up a little event called building routing data. And so as we actually go from segment to segment, this event gets raised, and we can do special things like we can check if that segment's a highway, and we can give it different weights and things like that. I just wanted to kind of point that out. But when we click the build, what we're going to do is we're going to open the shapefile feature source. And remember, this could be any kind of feature source. So it doesn't have to be a shapefile in particular. We're going to create an RTG routing source, or actually it's a static method, so RTG routing source.generate routing data, and we're going to pass in the path, or the path and the name of the RTG file that we want, and then we're going to pass in that feature source, and we specify whether we want, if the index already exists, if we want to rebuild it, or if we don't, and then we specify just a name. I think that name can actually be anything. And there's a couple different overloads, as you see. One that just takes the path name and the feature source, and it defaults, I think, to not rebuilding, etc. So really, that's kind of as easy as it is. You just have to make sure that the feature source is line-based. And right now, for multi-lines, we don't have very good support for it, but that's going to be coming in the next beta. If the product's already out, then we would have already supported it if you're looking at this kind of in the future. So once you do this, it would generate that RTG file, and you're pretty much good to go. Now, this is that event that I was talking about, this building road data, and it passes back these event arguments. And this is where you can go in and customize things. So let's look at the highway optimized method. So here what we're doing is we actually, in that E event, it looks like we're getting past the ID in here. Let's see, we can look what's all in there. So we get the line shape, we get the route segment, and the route segment's going to have the feature ID and other things in it. And what we're going to do is we're actually going to get that feature out of the feature source, and we're going to return this column's worth of information. And this column, I think, is says whether or not it's a highway or not. And we're going to see if that is an A4. That means it's a highway. If it is, we're going to give it a different route segment type. And the route segment type is just some information that we store inside the index, even though it's actually not used for anything except as a marker, so that if you're doing an algorithm later on, you can actually get that route segment type and it can mean something. It's just an integer. We just happen to be passing 2 into it. And because it's a highway, we actually want to include a weight. And so we're taking whatever the default weight is, and we're multiplying it by that number. So the weight's actually going to make it faster. So it will. So the line will actually seem shorter if you go on the highway. So that's a way that you can use some of these events to build kind of custom things into the data itself. All right. So let's take a look at the next one. The next one is building routing data event, and this is just we're just going to show really quick how you can also use that event to show the progress, because it's going to get raised on every segment that gets built. So here, we can show that it's building all these records, and we can cancel it. We can see, the progress of it. So that's kind of nice if you're integrating this in an application where the users can build, their own data. You can, take a look at this code and see, how you can integrate a progress bar like this in your system as well. So the next one is, let's see, is route avoiding certain areas. And so in this case, we have this polygon down here, and actually we're routing now, not trying to avoid it. And if we click on this, then we're going to get a new route actually avoiding that area. And so that's really nice if you have things like construction, or there's some special events, or if you wanted to do some sort of routing that included things like hazardous materials, where you had protection and isolation zones you wanted to keep people out of. You could do that. And actually, let's look at how we do that. So there's routing avoiding certain areas. And here it's actually it's set up very similar to the other way we do things. And in this particular case, what we're doing is that we're going to take that polygon shape at the very beginning. We're going to do a spatial query, and we're going to get all of the features that we want to avoid. So those are all the streets that are kind of out of bounds. And we're going to put them in a little collection of avoided features. Then we're going to go ahead and set up, our routing source. So the routing source doesn't actually have to be modified in this case. So this is a really good example of how this can actually be kind of in real time. So as these things are developing, you don't actually have to change the index to keep people out of certain areas. There's actually events that can be raised to do this. Let's see here. And what we're going to do is, if it's checked that says we want to avoid it, we're going to hook up a handler, and that handler is in the routing algorithm itself. And let's go ahead, and it's under the finding route. And so here's the actual event. And what we're going to do is that then inside this event, we're going to look at the feature coming in. That's where the algorithm is actually kind of looking for adjacent nodes, and we're going to see, is that adjacent node actually on this avoidable feature IDs list. So as it's trying to find its route, it's going to say, whoa, if it's on this avoidable feature, then let's pretend that it doesn't really exist. And so it's going to check on the start point neighbors and on the end point neighbors. And so this allows you to do the routing and actually avoid those areas. So that's how that works. The next one is route only in a specific area. And so this is if you had, if you were routing and you had certain lanes or areas that you wanted people to travel within. Kind of almost the opposite of avoiding certain areas. You could do this, and it functions basically in the same way as the avoiding areas, in that there's a group of features that are kind of valid. And so if the algorithm goes to route and it gets a feature from the index, and it finds that that feature isn't in the approved kind of a road that I can take, then it's going to pretend that it doesn't exist. And so here you have it routed outside. And then if I want to specify the area, it's going to route it inside. And you see how it just barely clips that end, trying to get the most efficient path in there. The next one is using different algorithms. And in this particular case, right now, we're defaulting to Dijkstra's graph. And you can see its path going through here. We can also use something like an A star. And that's going to get a slightly different path. And then we have bidirectional, and these are the ones that ship with it by default. And it looks like it takes the same path as Dijkstra's. And each of these different algorithms have different strengths and weaknesses. Just to give you my understanding of how these work, the Dijkstra graph is is one of the slower ones because it looks at the entire road network and it'll solve perfectly what the absolute shortest path is. So if for some reason the system, to get the shortest path, you actually had to go backwards and then around and down and over here, then the Dijkstra is going to solve that. Where with the A-star looks towards the endpoint, and so it's gonna be basically ignoring paths that go backwards or that go kind of sideways, and it's gonna be kind of in a cone moving towards this end path, which works really good when you have very dense street networks. It doesn't work so well if you have very specialized networks where you might have to go backwards and around and kind of a maze type of thing. And so you can find a lot of these explanations of these algorithms online as well. You can also implement your own, and we're going to be implementing some other ones also. The bidirectional, it actually starts at both sides and then tries to kind of meet in the middle, and that one's good if you want to take advantage of multiple cores and routing, and each one's trying to find its path to the other. And let's actually look at the source on how we just swap those out, because it's fairly simple to see. There we go. So in here we have our routing source again. That's our index, that RTG file. We have our engine, and inside the constructor for the engine we actually have a little get algorithm method that's actually going to pick it out. And so here it is, and based on the text in that combo box, we have a switch set up to say new A-star routing algorithm, a new Dijkstra routing algorithm, or a new bidirectional. So you could see that you could just add another case to the switch, and you could get another different algorithm that gets plugged in here. So they really fit inside of each other very well, and it's very easy to set up. Routing directions, so this is going to be the turn-by-turn directions. So let's go ahead and find the route there. And so this really is kind of mimicking what we get in that routing result. So we're going to get, actually we don't get the road name in the routing result. You have to go and grab that, because in the actual index itself, we don't keep the road name, because it might not be a road. You might only care about the feature ID. You need to actually go through in the feature source and pull out what the name is. It could be that your name is actually a composite of many fields, so we didn't even want to guess on that. And then we have the direction, starting here, and then we have the length of each one. Now here where it says forward and forward again, it's because we actually there's multiple segments. The data is actually, like, let's say in this particular case, this could be one segment and that could be one segment, and there actually could be separate actual features, and so you're going to get forward and forward. But you can pretty easily just collapse these and add the length up together and just say forward once, basically roll it up by road name and just do a filter on it. So let's actually take a look at some of those routing results. Let's see, this one is routing directions. Okay, here's we're loading up the table, and basically here's the routing results object here, and what we're doing is we're calling this show turn by turn directions, which is basically loading that grid that we saw, and what we're passing in are all the route segments, because the route segment has a lot of different useful information, and also the features as well. But if we look at the routing results, where is that guy? Okay, it returns the distance, the total distance of the route. It returns all of the features in order that represent the route. It also returns the a multi-line shape, which is the route itself. So if you just want to plot that directly on the map. And it also includes a collection of all the route segments. And route segments, let's just look at one in particular, had things like the endpoint, the driving direction, like whether this was a straight forward or a turn, based on the next route segment. It also has the adjacent endpoints, the start point, the start adjacent IDs, and the weight that this particular route segment had, along with the type of it. I think that's in here somewhere. Yeah, the route segment type, which is actually an integer. That was that number we had looked at previously, where you can just kind of make up. So here, you could tell if it was a highway just by looking at that. But it's kind of your own thing to implement. And so you can take a look at the code here on how it loads up that grid. It's fairly straightforward. Okay, so the next one is extending routing source, and in this particular example, it demonstrates how we extend that routing source class. And remember that routing source is like the index, and we ship it with an RTG routing source, where we take the features and we create a flat file and optimized structure. But in this sample, what we do is we actually create a new kind of routing source that's really just pretty dumb. And what it does is that you pass it in a shape file, and it reads in real time what the adjacent nodes are. And so it's not optimized at all, but this just shows how you could do routing just against a shape file with this particular routing source. It's just that shape files weren't really designed to do really fast routing, so you can get an idea of what the speed difference is, to do a relatively short route where we're doing everything dynamically. And there it is. It took a couple 2 or 3 seconds, where the other ones it's in milliseconds when you use the an optimized structure for it. But it's an interesting sample, and it just takes a look at how you can extend that routing source. And we'll just take a look real quick. Where is it? There we go. And the interesting part about it is actually it's down here. We included the class in this file, even though usually a class should be in its own file. We just did it here so it's easy to find in these samples, and that the code is all together in this one file. And here we had to override this get route segment by feature ID core, and this get adjacent feature IDs. And this is kind of actually the main thing, because as the routing algorithms are trying to find the where it should go, it's going to be constantly calling in to want to know what are the adjacent feature IDs. And so in this particular case, what we do is we actually do a spatial query. So we get the features inside the bounding box of that shape to find out what are all the other shapes that connect to it. And so we kind of walk it that way, and this is just really, really slow. And this is why you build a routing index in the first place to create this graph and store it in a very optimized method. But it kind of shows you behind the scenes maybe this could be something that you would use to build a routing index yourself, a very simple one. All right, intermediate point support. So this is where, up until now we've just had a start and an end, and here we're going to do something with an intermediate stop. So, here we've added intermediate stop 1, and you have to travel down to that stop and over. And with our system, you can easily pass in multiple stops. On the routing engine itself, I think there's a stops collection, and so you just add as many intermediate points as you want, as long as they're in order. Currently, the system, and this is just for the beta, so this might, if you're watching this in the future, it might support it. But for the beta, if you give it a number of stops, it won't actually find out which stop is in what order to do the stops in the fastest or the most optimal path. So right now you have to include the stops by hand, but that's something that we're going to be adding. So just to let you know that. And that's pretty easy to look at the sample and see kind of how it's doing it. We also have the service area definition, and this is something where you pick a point, you give it a speed, you give it a driving time, and it'll generate a service area based on a specialized algorithm. And so that's what it's come up with based on the the density of the line network. Obviously, it didn't go to every line and calculate it. There's more of a generalized algorithm for this, but it's a very industry standard one. So, and that one's pretty easy here. We'll take a look at that service area definition because it's really not much to that. We make that pretty easy. So, you create a feature source. I'm sorry, you get your routing source, and here, we're using that RTG file, the RTG routing source. And let's see, where's the actual call? It's a static method on the routing engine called generate service area. And it looks like you pass in a routing source, a feature source, and a starting ID, and you can probably pass in a position as well, along with a time span of your driving time, an average speed, and a distance unit of the speed. So whether the average speed might be 20, but then the distance unit is going to be 20 miles per hour, 20 what, and then the geographic unit. In our case, it's decimal degrees. And that's going to return a polygon shape, and then the whole rest of the code is actually just to, put that polygon shape on the screen and show it. So that's a very easy to use API, and very powerful as well. The other one is optimized road type, and let's see, what does this one look like? Oh, and this is one where we can actually analyze the road type in real time. Well, we can either do it in real time or we can build specialized indexes. But in this particular one, we want to say it's on foot. So we want to avoid all the highways. Otherwise, you could say, well, if it's by car, then you want to actually do this route. If it was on foot, you want to do this other route. And there's a whole bunch of different ways we can do this actually. And in this particular case, it looks like we actually have a different RTG file. Nope, hold on. It looks like there's an event here. Yeah, it looks like it looks like we're hooking the event up, and then in the actual algorithm finding the path, as it goes through, it looks to see if that rogue segment type is 2. And if it is 2, then it adds it to the highways collection. Otherwise, it adds it to the roads. And so here, kind of in real time, we're analyzing the features, and we're trying to determine if it's a highway or not. Another way that you could do this would be you could generate an index that just leaves the highways out. If you absolutely never want to be on the highway, you could do that as well. That's going to be a little bit faster than actually interrogating the records as they come in. So it just shows a different way. But obviously, to do the lines, to actually generate 2 index files is relatively straightforward as well. So it's just another example of how you can do this stuff real time. And I think that is pretty much it for the samples. There is also a routing explorer that we're working on. And let me go ahead and run that. Bring it over here. And so what this allows you to do is it allows you to create an RTG index for a shapefile if you don't have one. It allows you to select shapefiles to open. So let's go ahead and I'll just open one real quick. And here we're going to go ahead and pick Austin Streets. All right, so this is the little cutout of data that we have for Austin Streets. And we can do things like right-click here and say route from here. And we can go down here and say route to here. And it's going to create that, and it's going to show us our, let's see, we click that, we'll get the turn-by-turn directions, get all the features. It'll take a look at the route time, the length. We can also right-click and we can add points, like here, add a stop. We can add a stop up here. We can add one over here. And it'll switch all those around and give us our new route times. You can also select your stops and move them up and down. See all kinds of crazy things that it can do. You can delete them as well. And that deletes all of them out. and it's just going to pick the closest segment that you're on. You can also come up here and you can pick the different algorithms. You can also, if you have a large data set, you can set a timeout in seconds of how long it takes to find it. You can also look at the distance here in different units. What I use this for typically is to generate the routing index. And actually, if you open a shapefile that it doesn't have a routing index, it'll actually ask you. It'll say, "Hey, there's no routing index. Would you like us to build one?" It'll build one for you with the same name as a shapefile, just with the RTG and RTX extensions. And this is nice to just kind of play around with your data and visualize it and kind of test it out. So you'll find all this stuff, under your Start menu, under Programs, ThinkGeo, and then under the Routing product. All right, so I think that's it for the samples then. Well, thanks for watching. I appreciate your time, and for more videos, visit gis.thinkgeo.com, and more specifically, go into the discussion forums and go in the developers blog area. We also have a code community out there. You can reach that with code.thinkgeo.com. So check that out. We implement a whole bunch of different samples and all kinds of stuff to basically show you how to get the most out of all the MapSuite products. All right, thanks and have a great day.